Yesterday we were using the Pythagorean theorem to find missing sides. That's what we just reviewed. And we sort of stopped because we ran out of time at page 7. Yeah. Example 3. This one? Okay. Yes. So in this one, the way we did it here, we actually wrote it out as a plus, but then we ended up having to subtract it anyway. We could have gone faster if we had just gone like this. 10 squared minus 8 squared equals x squared, which is 100, just one second, minus 64, 36. Yeah. Yeah, it's kind of like we're cheating the algebra a little bit. We're starting like a couple steps down. But because there's only 2 ways to do Pythagorean theorem, you can do that. You'll just, it's a way of remembering. It's like a short form. Okay? Oh, yeah. There you go. Okay, and then we ended the class with me going on and on and on about how great trigonometry is for solving real-life problems. Okay? So now we're going to solve a real-life problem. We want to know how long this road is. Kids are in the back going, oh, how long are we going to be up this? And you're going to pull out your calculator and say, well, considering that we're climbing a height of 7.2 meters over a distance of 19.57 meters, because you would know that in your head, then you could do the math. Okay, so maybe that's not as practical a problem as it could be. All right, so it's just Pythagorean theorem, right? We got a triangle. We've got the 2 short sides. So because I have the 2 short sides, am I going to be adding the squares or subtracting them? I'm going to be adding them, right? So 7.2 squared plus 19.57 squared equals x squared. And the numbers are not very friendly, which is a little more like real life. Plus 19.57 squared. You get some number like 434.8249. And then you're going to have to square root that. It's a positive square root, by the way. Not, because it's it can't be a negative number. So square root of the answer, and I get 20.85. Anybody get around 20.85? Yeah? Okay, and that would be the length there. Okay. Okay, example 6, a wheelchair ramp. It's a little more realistic. Wheelchair ramps are never that steep. Why not? They're usually quite long. They have a low slope. Why wouldn't they be shorter with like a more vertical slope? You ever try to roll a wheelchair? You ever sit in one? You don't want to go vertical. You want it to be a nice, gentle slope. It would be treacherously dangerous for it to be quite vertical. So a wheelchair ramp is being built for an entrance to a restaurant as shown below. Determine the horizontal length of the ramp. Okay, so we have the long side. If we start with the long side, we're going to have to do subtraction. So we're going to go 27.8 squared plus or minus? Minus 2.6 squared equals x squared. So let's punch that in. 27.8 squared. It's going to be minus because we started with the long side. Yeah. Minus 2.6 squared equals 766.08. And then I have to hit square root of that. 27.68 feet, approximately x. Notice that the answer is pretty darn close to the long side. This is a little bit shorter. And that's because the slope is very gradual, right? And the way they usually get around that with restaurants is like they don't have a straight run. Usually you'll see it goes one way and then it comes back up and it kind of winds. And that way they can have a gradual slope. Now, you should know if you've made a mistake just by how the number looks. If I would have got a number bigger than 27.8, let's accidentally added this. If I would have got a number bigger, looking at this triangle, that should sort of alert my brain to the fact I made a mistake. Because in all right triangles, this side has to be the biggest number. If I calculate it and I get a bigger number down here, that tells me I did something wrong. This has to remain the longest number. I got something smaller, so it's okay. Okay. And it's pretty close because this is a short side here and this is quite long. Okay. All right. How many of you started this assignment already? Anybody? No? Okay. So do this assignment. Do this. But I do want to start the next section. I will give you more time to work. Tomorrow, I'll introduce you to lesson 3. Learning about lesson 3, because it's distinct, it's different than doing this, it won't mess your brain up. Like sometimes in math stuff, you kind of want to get good at one thing before you go to the next, but they're not that closely related, so it won't mess you up. So let's go over to page 10. Because I want you to learn one new skill today. Okay. I already introduced you to the word hypotenuse. And for all practical purposes, the hypotenuse is simply the longest side of the triangle, the longest side. What else can you, if you had to describe where it is, it's always in the same place. Where is it? In this triangle, it's across from the little 90-degree angle, right? So there's your 90 degree, and you go all the way across, that's where you find your hypotenuse. Always. Another way to describe it, you would say that it doesn't touch the 90 degree. Right? This side does. Like this side actually helps make the 90 degree, and so does this side. But the hypotenuse, it's away from it, it doesn't touch it, it's across from it. Okay? So it's the longest side. You could also say that it's across from the 90-degree angle and doesn't touch it. Okay? This is very important to be able to quickly identify, correctly identify where the hypotenuse is. If you can't do that, you can't do the whole unit. So it's critically important. Okay? So over here, this page, where's the hypotenuse in this triangle? Is it this side? Is it this side? Is it this side? Yes. Okay? It's not this symbol I was worried about. It's this one. That's the 90 degree. I go across, and there's the hypotenuse. It's also the longest side. Visually, it should look the longest too. So this is the hypotenuse. You don't have to write out the word. I like writing it out because I like the word. It's pretty cool. And it's got pretty unique spelling. So it makes me feel good about myself that I can write and pronounce the word hypotenuse. So I write it out. If you don't want to write it out every time, you can just put like H or HYP or something. Hype is also a pretty cool word. Okay, this one here. Where's the hypotenuse? This side? This on the bottom? Over here? Yes. There's the height. This one here, is it here? No? Is it here? Yes, it's here because it's across from the 90. So this is the height. This one here, is it here? Nope, because this side actually touches, like forms the angle. Is it here?
Yes.
Yeah, it's on the bottom here, so. Top? Left side? Right side? Yeah. Okay, describe to me where it is.
On the side.
Which side, left or
The
right?
one side. Right.
The right side. Yeah. Yeah.
Yeah.
There you go. Do you know why when we're learning skills we do something over and over and over again? I mean, you understood the concept right away, but I'm doing it a bunch of times. Why?
So it can stick in our brain.
Yeah, so that our brain recognizes that it's very, very important. So by doing it over and over again, it burns into your long-term memory. Okay? Hopefully 20 years from now, you'll be able to identify and label a hypotenuse in a triangle because you did it over and over and over again, right? And all skills work that way. If you teach someone how to throw a baseball once and they understand how to do it, you show them the proper mechanics, and you get them to throw the baseball and they do it properly, are they going to be great at throwing a baseball? They have to do it over and over and over again. Yeah. Anybody watching basketball right now? Yeah. Yeah, the Raptors are looking like they're coming back. It's the first time the Bucks have lost 2 games in a row, I think all season. And I mean, those players, they shoot basketballs like, they'll go out an hour, like these are people that have shot basketballs like hundreds of thousands of times. And they'll go out before the game and shoot for like half an hour. Repetition, right? So that becomes automatic. All right. And how would you describe where the hypotenuse is in this one?
On top.
Top? Everybody agree?
Yes.
All right. And where would you describe it on this one? On the right side, sure. Okay, there we go. We're able to identify and label the hypotenuse. That's very important. Going back a page. Now, there are 2 more names for the other 2 sides. One of the sides we call opposite, and one of the sides we call adjacent. Now, those sides, the labels for those sides change depending on which angle you're using. Okay? So, normally in a triangle, we're dealing with one angle at a time. So that's usually this little symbol here, theta. So we say that this side over here is opposite from angle theta. And we say that this side here, because it actually touches it, it's adjacent to angle theta. Now the word adjacent is an English word that doesn't get used a heck of a lot. Does anybody know what it means? Just means beside. Yeah. So this computer monitor is adjacent to this computer monitor. It's beside it. So we use the word beside more commonly than we use the word adjacent. But it means next to. Okay? So this side we label as opposite angle theta, and this is adjacent to angle theta. Okay. So see here, here's the angle. Here's the side opposite. So opposite from theta. And this is adjacent to theta. Here, there's theta. So there's the opposite, and there's the adjacent. Okay? Now, so unlike the hypotenuse, which is always, you can just look at any triangle and just label it, The other two sides depends on which angle you're talking about. In this, if I was talking about the angle here, these would switch. It depends on which angle, okay? So, looking over here, if this is the angle I'm using, theta, which side is opposite of theta? Left or top? The top. The top is opposite. So you write opposite of theta. You don't have to put the of theta, but I do, because then it's really clear to me in my brain what I mean. Okay. And this one here is actually next to it. It's actually touching it and next to it. And the word we use is adjacent. Adjacent to theta. Okay. So this one, which side is adjacent to theta here? On the bottom or the side? The side. This side is adjacent to theta. Which means this bottom side has to be the opposite of theta. Okay. This is my angle over here. What do I call this side? Everybody agree? Let's just put ADJ. What's this side then? OPP. Awesome rap song from the early 90s by a band called Naughty by Nature. Everybody knows it? If you don't know it, you should look it up. You know it? Yeah, you're down with OPP. Yep. Can you name the sample they used? No? Jackson 5? Okay. Okay, this is hype. What's this side called? That's adjacent, because it's actually touching the theta. What's this side over here? Opposite. Good. Okay, what's on the top here? That's opposite. And this is adjacent. Okay. Everybody's getting this? This is, you cannot do this entire unit at all unless you can do this. This is in every single trigonometry question you're going to do using those buttons. The sine, cosine, tan buttons. The first step is always the same. That's to label the triangle. So you have to be able to do this. So if something's confusing, make sure you see me, make sure you ask, because you can't move on unless you can do this, right? It's like trying to run before you can walk otherwise. What's this side down here? That's adjacent to theta, and this is opposite. Good. This is theta here. What's this side down here? Opposite. And this side? Adjacent. Okay. This is theta. What's this side down here? That's opposite. And this is adjacent. All right. Fantastic. So you've learned a new skill. We're not going to move on to the next thing. Is very abstract, so it's a little harder for the brain to catch on to it. Once you get the hang of it, you'll be okay. So for the rest of today then, I just want you to finish your Pythagorean theorem questions. Okay? Good work.